Okay, here are two questions. Find out the distribution ratio of transverse of TO modes. ठीक है, TO modes, TO modes. डिस्कस द ट्रांसपोर्ट मेरा यूवी रीजन में ट्रांसपोर्ट ऑफ ये प्लाज्मा ऑप्टिक्स में जानना होगा। और यहाँ पे ये है TO modes और ट्रांसपोर्ट ऑफ मेटल इन यूवी। लॉन्गिट्यूडनल प्लाज्मा ऑसिलेशन अलग टॉपिक शायद है, लेकिन ये भी टॉपिक है अगर एरो से अगर पूछा तो। Find out the wave vector dependence of dispersion relation और longitudinal oscillations in Fermi gas। तो यही है शायद longitudinal oscillations। ठीक है, ये रहा, ये हुआ, ये इधर अलग 5 मार्क्स का। सो ये भी है प्लाज्मा ऑप्टिक्स, लॉन्ग वेवलेंथ डायलेक्ट्रिक रिस्पॉन्स। लॉन्ग वेवलेंथ कब? जब ओमेगा k इज इक्वल टू जीरो, k इज इक्वल टू जीरो, तो लॉन्ग वेवलेंथ डायलेक्ट्रिक रिस्पॉन्स हो गया। ठीक है, लॉन्ग वेवलेंथ k जीरो मतलब लॉन्ग वेवलेंथ of an electron gas is obtained from equation of motion of free electron in the electric field. M acceleration is equal to minus EE. If x and e have time dependence, e to the power minus I omega t, then minus omega square mx is equal to minus e e. X is equal to ee by m omega square. The dipole moment of one electron is minus ex is equal to minus e square e by m omega square, and the polarization is defined as dipole moment per unit volume is p is equal to minus nex is equal to minus n e by m omega square, where n is the electron concentration. The dielectric function of frequency omega is epsilon omega is equal to d omega by e omega. d by e is equal to 1 plus 4 pi p by e. So ये क्या होता है? d होता है तुम्हारा e प्लस 4 पाई p, ठीक है, या फिर d e प्लस p बाय एप्सिलॉन नॉट। ठीक है, ये तुम्हारा SI यूनिट्स में दोनों लेते हुए चलेंगे। CGS में है तुम्हारा 1 माइनस 4 पाई एन ई स्क्वायर बाय एम ओमेगा स्क्वायर। SI में है तुम्हारा एप्सिलॉन 1 माइनस एन ई स्क्वायर बाय एम ओमेगा स्क्वायर। तो वहाँ पे ई नॉट है एक। प्लाज्मा फ्रीक्वेंसी इज ओमेगा पी इज डिफाइंड बाय द रिलेशन ओमेगा पी का होल स्क्वायर इज इक्वल टू 4 पाई एन ई स्क्वायर बाय एम। ठीक है, सो ओमेगा स्क्वायर is equal to this. So E epsilon omega is equal to 1 minus omega square p by omega square. ठीक है, SI units में n e square by epsilon naught m. A plasma is a medium with equal concentration of positive and negative charges, of which at least one charge type is mobile. In a solid, the negative charges of conduction electrons are balanced by an equal concentration of positive charge of ion core. We write the dielectric function 8 as 10 plotted in figure 1. So this is the dielectric function. Dielectric function epsilon omega or epsilon omega comma 0. ये long wavelength limit of free electron gas versus frequency in units of the plasma frequency omega p. Electromagnetic waves propagate without damping only when epsilon is positive and real. So if ये वाला, ठीक है, omega is positive and real, omega is this, ठीक है, this is omega being positive in this region ऊपर वाला, ठीक है, omega is positive and real. Electromagnetic waves are totally reflected when medium epsilon is negative. So शायद एक पॉइंट छोड़ा है, लेकिन let's move on. If the positive ion core background has dielectric constant labeled as E infinity, epsilon infinity, essentially constant up to frequencies well above omega p, then it becomes omega epsilon omega is equal to epsilon infinity minus this thing. ठीक है, सो इसमें एक एप्सिलॉन इन्फिनिटी कॉमन आ जाएगा, वहाँ था तुम्हारा ओमेगा पी स्क्वायर था, ओमेगा पी बार हो जाएगा, और ओमेगा पी बार इज डिफाइंड एज ओमेगा पी बार स्क्वायर 4 pi n e² by epsilon naught m, epsilon infinity. Notice that epsilon is equal to 0 at omega equal to omega p bar. ठीक है, epsilon is 0 at this point, so it's here. ठीक है, this point इसमें तुम्हारा ये क्या होता है, ठीक है, ओमेगा बाय ओमेगा पी तुम्हारा क्या है, यहाँ पे इस पॉइंट पे 1 है, ओमेगा बाय ओमेगा पी, ओमेगा पी है, ओमेगा पी बार, ओमेगा पी बार होना चाहिए, या ओमेगा पी भी, नहीं नहीं ओमेगा पी, दोनों में सही है, ठीक है, दोनों वहाँ पे हो रहा है, ओमेगा इज इक्वल टू ओमेगा पी बार. Dispersion relation for electromagnetic waves, these are this में इन नॉन, ये शायद टीटोर है, थोड़ा टॉपिक से लेकर लिखना शायद जरूरी होगा. ये है तुम्हारा, ये है इन अ नॉन मैग्नेटिक आइसोट्रोपिक मीडियम द इलेक्ट्रोमैग्नेटिक वेव इक्वेशन इज दिस double time derivative of d which is equal to c square nabla square e, if a double time derivative of t is is equal to nabla square e divided by mu naught. ठीक है, स्क्वीज है सी स्क्वायर या डिवाइडेड बाय म्यू नॉट. वी लुक फॉर सोल्यूशन ई डायरेक्टली प्रोपोर्शनल टू एक्सपोनेंशियल ऑफ आई ओमेगा टी माइनस में एक्सपोनेंशियल ऑफ आई के डॉट आर एंड डी इज इक्वल टू epsilon of omega and k into E. Then we have dispersion relation for electromagnetic waves. Epsilon omega square is equal to c square k square. Epsilon omega square is equal to k square by epsilon naught mu naught. Okay. This relation tells us great deal. Epsilon real and greater than 0 for omega real, k is real, and transverse electromagnetic wave propagates with phase velocity c by epsilon half. Epsilon real and less than 0 for omega real, k is imaginary and wave is damped with a characteristic length 1 by k mod. Epsilon complex for omega real, k is complex and waves are damped in space. For epsilon equal to infinity, this means the system has finite response to absence of applied force. Thus, poles of epsilon define the frequency of the free oscillation of the medium. Epsilon 0, we shall see the longitudinal polarized waves are possible only at zeros of epsilon. Transverse optical modes. So, the dispersion relation 14 with 11 becomes this: epsilon omega square is equal to c square k square. ठीक है, या epsilon naught omega square minus omega p bar square. For omega less than omega p, we have k square less than equal to 0, less than 0. So k is imaginary. The solution of the wave equation are of the form exponential minus mod of kx in the frequency region of 0 to uh, omega p bar. Waves incident on the medium in this frequency region do not propagate but will be totally reflected. ठीक है, and gas transparent when omega is greater than omega p bar. Here the dielectric function is positive real. The dispersion relation in this region will be written as omega square is equal to omega p bar whole square plus c square k square by epsilon in infinity. This is CGSA. This describes transverse electromagnetic waves and plasma. Figure 2. Transverse electromagnetic waves and plasma. Dispersion relation for transverse electromagnetic waves and plasma. The group velocity Vg d omega by dk is a slope dispersion curve. Although the dielectric function is between 0 and 1, the group velocity is less than velocity of light in vacuum. ठीक है, इधर क्या है ओमेगा बाय ओमेगा पी, इधर क्या है सी के ओमेगा पी. The values of plasma frequency omega p and free space wavelength lambda p 2 pi c by omega p for electron concentration of interest are given below. A wave will propagate if its free space wavelength is less than lambda p, otherwise the wave is reflected. Okay, it's a wave will propagate if free space wavelength is less than lambda p. Okay. Otherwise it will be reflected. Transparency of metal in ultraviolet region. From the preceding discussion, the dielectric function will we conclude that simple metals should be reflect light in the visible region and be transparent to light in the high frequency. A comparison of calculated and observed cutoff wavelength is given in table 1. The reflection of light from metal is entirely similar to the reflection of radio waves from the ionosphere. ठीक है, ionosphere में ये चीज़ होता है, the reflection of light from a metal free from metal is entirely similar to the reflection of radio waves from ionosphere. तो मेटल में जो होता है सेम चीज़ आयनोस्फीयर में होता है कि जो रेज रिफ्लेक्ट हो जाता है. फॉर द फ्री इलेक्ट्रॉन्स ऑफ आयनोस्फीयर मेक द डाइलेक्ट्रिक कांस्टेंट नेगेटिव एट लो फ्रीक्वेंसीज. ठीक है, एक्सपेरिमेंटल रिजल्ट. ठीक है, तो रिफ्लेक्ट दे इधर देखो, हाई वेवलेंथ रिफ्लेक्ट हो रहा है तो लो फ्रीक्वेंसी भी रिफ्लेक्ट होगा. एक्सपेरिमेंटल रिजल्ट ऑफ ठीक है, सो इट इज़ रिफ्लेक्टेड इन लो, द हायर इन ट्रांसपेरेंट इन हायर फ्रीक्वेंसीज. ठीक है, experimental result for NSP is n is equal to 4 into 10 to the power 18 per centimeter cube as shown in figure 3. The plasma frequency is 0.9. तो रिफ्लेक्टेंस ये पॉइंट में आके रिफ्लेक्टेंस कम हो जा रहा है. ठीक है, यही बताना चाह रहा था. ट्रांसपेरेंसी ऑफ मेटल इन अल्ट्रावायलेट रीजन या फिर ट्रांसपेरेंसी इन हायर फ्रीक्वेंसी रीजन. जो अल्ट्रावायलेट रेज तो आता है. ठीक है, नहीं लोअर ये तो जो भी लॉन्गिट्यूडनल प्लाज्मा ऑसिलेशन इसका भी क्वेश्चन है. ठीक है, यहाँ पे फाइंड आउट द वेव वेक्टर डिपेंडेंस ऑफ द डिस्पर्शन रिलेशन फॉर लॉन्गिट्यूड ऑसिलेशन इन फर्मी गैस. तो ये यहाँ पे इस वीडियो का पार्ट 2 चालू हो रहा है. ठीक है, so here it begins. Longitudinal plasma oscillation. The zeros of electric function determine the frequency of longitudinal modes of oscillation. Thus, epsilon at omega L is equal to 0 determines the longitudinal frequency omega L near k equal to 0. ठीक है, तो ये longitudinal oscillation k equal to 0. By geometry, ठीक है, epsilon omega L is equal to 1 minus omega p square minus omega L by omega L का square is equal to 0. Why not omega p bar? I don't know, but okay, moving on. By geometry of longitudinal polarization, we have there is a depolarization field E is equal to minus 4 pi p discussed below. Thus, D is equal to E plus 4 pi p equal to 0 for longitudinal wave plasma. More generally in crystal, SI unit is a D EP, DEEP, या D epsilon naught E plus P is equal to 0 for an electron gas at 0. The dielectric function is equal to this, whence omega L is equal to P. ठीक है, omega L is equal to omega P. Thus, ठीक है, thus there is free longitudinal oscillation mode. Figure 4. Arrows indicate direction to electrons. Free longitudinal ये mode of electron gas described in 15 ash, the low frequency cutoff. 15 यहाँ पे लो फ्रीक्वेंसी कट ऑफ, ठीक है. Of transverse electromagnetic wave. Thus, there is a free longitudinal oscillation mode of electron gas at plasma frequency described in as low frequency cutoff of transverse uh, magnetic waves. So, low जहाँ जो कट ऑफ है वहाँ से ये चालू हो रहा है. Longitudinal plasma oscillation with k equal to 0 as shown in figure 5 is as uniform displacement of electron gas. In thin metallic slab, the electron gas is moved as a whole with respect to the positive ion background. The displacement U of electron gas creates an electric field E equal to 4 pi NEU that acts as a restoring force of the gas. The equation of motion is NMD, Nm acceleration is equal to NEE is equal to 4 pi n square E square U, or is equal to du plus omega p is equal to 0 is equal to omega p is equal to 4 pi ne square by m under root. This is the equation of motion for simple harmonic oscillator frequency omega p. The plasma, the expression omega p is identical with omega 9, with equation 9. Equation 9, 4 pi n e square by m, 4 pi n e square by m. Yes, that's right. This equation of motion of simple harmonic oscillator of frequency omega p plasma frequency. The expression for omega p is identical with 9, which arose in a different connection. NSI, the displacement unit U, displacement U creates electric field E is equal to NEU by epsilon, whence omega p is equal to N E square by epsilon m under root. A plasma oscillator, a plasma oscillation of simple wave vector has approximately the frequency of omega p. The wave vector with dependence of dispersion relation for line oscillation in a Fermi gas is given by omega 0 to omega p 1 plus 3k square v square f by 10 omega p omega square, where vf is the electron velocity of Fermi gas.